All right, this is a video for Python Learning Module 3, where we're going to talk about using lists, tuples, and maps. Okay, these are data structures that are available in the Python language. Specifically, lists is something that for our class, you got to become very proficient in. Lists are very powerful in the Python language, but also in other languages. They're just not called lists in other languages. Typically, they're called arrays. So the purpose or the objectives of this learning module is to understand the list of the use of these data structures, as well as how they're specifically used in the Python language. So, all right, so let's kick things off with a list. So basically using this bottom example down here, as you can see, a list is just a collection of things. Okay, very simple. And you can see the things, plural, are separated by a comma. So I have a string, another string, another string, and another string. So these are just a list or a collection of things. Okay, that's what a list is, simply. They're very similar to arrays in other languages. There's differences, don't get me wrong, they're not the same thing. There are differences, but it's very similar to arrays. Okay. So when we're working with very large amounts of data, these lists come in really handy. Okay, so some things that we are used to right now, we're used to creating variables like x equals 13. Well, a list is no different. You create a variable, you name it, so you have to use the standard naming conventions. I called mine my list, and you set it equal to something. Now, a list is represented by, or is indicated by, the square brackets. Okay, so you have, these are the square brackets, those are the curly braces, these are the parentheticals. Okay, a list, you can recognize a list by the square brackets. So you create the variable, you name it, you come up with the name of the variable, and you set it equal to, you start off with the empty, it's right now it's empty, but you have the opening square bracket and the closing square bracket. And now you can insert things. Like let's just say I want to insert a bunch of numbers. Let's say 20, 13, 5, 10, 19, 10. Okay. So this list, which is a collection of things, contains 1, 2, 3, 4, 5 things. Okay. I could do just something as, additionally, something as simple as, let's just say another list equals the square brackets, and let's just make it strings now. Let's just say I want to get milk, eggs, and orange juice. Okay, so it might be a grocery list. Okay, I just created two lists right here. It's a collection of things, and now I want to just see them. Let's just say I want to print my list and print another list. And save that, and I can run it. And you can see over here in the output, so I wrote all of my code here in this file. I actually don't need the x equals 13 anymore. That was just I wrote everything in this file here on the right. This is my Python script where I created one list which has the variable name my list. I created another list which has the variable name another list, and it equals these values here, and then I printed them to the screen. And here's the output. And you can see with printing it, it just prints the entire list. So there's no pretty formatting or anything like that. Okay. Now there's a huge advantage with lists, something that you don't get, because I could think about this. I could say, I could create some string called grocery list equals, let's just make it a string, milk, eggs, orange juice. Okay, that's a string right there. So I could even say print grocery list. Okay, and then I could run this module as well, and you can see milk, eggs, orange juice. Then it prints this list of numbers, and then it prints my other. So two different data structures. Make sure you understand this. This data structure right here, this is an actual list data structure in Python. This is just simply a string, and we've learned strings already. Okay, but here's the big difference. If I want to access, let's say, the word eggs that's in my data structure, I can do it extremely easily with a list. I cannot do it that easily if it's a string. So if I want to change, let's say, eggs to bacon, okay, I actually would have to I'd have to create a new string that has the contents of this string minus the eggs. However, with a list, I can access each one of these items individually. And we'll see that here shortly, how to do that. You got to use an index. It's like using an index when we accessed an array in the C and C++ language. This is item 0 in our list, this is item 1 in our list, and this is item 2. Okay. A string, you can't do that kind of stuff too. So you could say print, let's say print another list, which is our gracious list, just like we use an array. Let's just say I want to print eggs, because I'm printing another list with the square brackets 1, so I'm using that as an index. So I'm wanting to print item 1 from our list to the screen. And so we should see eggs over here. Because remember, everything is indexed off of 0. That's the 0 item, 1 item, 2 item. Okay. So that's the difference between strings and lists. So we'll go ahead and get rid of that string so that it's not any more confusing. And I don't want to print that anymore. Okay. So that's basically the introduction of lists. List is a collection of things, much more powerful than strings, especially when we're talking about large amounts of data, and we want to be able to access individual items in our list. Okay. This slide here, we're talking about just that, why it's different than a string and how much easier it is to access contents of a list versus trying to access contents of a string. Okay. All right, here's the structure, the syntax in Python on how we actually create and use lists. You've got to come up with some variable name and use the standard naming convention of variables. You come up with it, and this is going to be the name of the list so that you can reference it later. Then you have the equal sign. Then you have the hard brackets, the square hard brackets, the opening one and the closing one. Remember, everything's symmetrical. And then each of the items in the list is separated by a comma. You can have different data types and you can mix them. So for example, I can say, well, let's just not change anything. I just want to say, let's just add that to it. So in my list now, I've got the concept of strings and I have the concept of integers. I've got both of those data types represented in this list. And you can see it still gets printed. So you can mix the data types inside of a list. So that's one difference. Another difference from arrays that we can't do. We can't mix the data types again. Okay. Now I'm pulling on this thread. Now that we have a list, so what? Well, the so what is now we can reference each individual item in the list that we might have. Okay. When you have a list, let's look at our screen right here. When we have a list, let's say we have my list, first, second, and third, the index position of those items starts off with 0. Just like with everything that we've been talking about, computers start counting at 0. The first item in this list is actually with an index position of 0. Index position of 1, index position of 2. So if you wanted to access the number 13, that's actually index position 1. If you wanted to access the number 5, the third item in the list, then that is index position 2. Okay, so make sure you remember that, and that all the counting starts at 0. All right, now there's different ways that we can manipulate lists, that we can change the contents of lists, we can add items to the list, we can remove items from the list. Okay, the easiest way to access items in the list is in Python. It's called slicing. Okay, so where we actually we use the indexing concept. So let's go. So I want to print from my other list these 3. Let's add some other things. I want to add, well, let's add bacon and pancakes. Okay, I just wanted to add a few more items so we can show this slicing concept. So remember, if I want to access an item in the list, then I would put, let's say I want to access the third item in the list. Okay, then that's going to be, let's say I want to access, there's item 1, item 2, item 3. However, the index position is index position 0, index position 1, index position 2. So let's say I want to access that item and I want to print it to the screen. Save that, run it, and you can see I accessed that third item in the list, orange juice. Okay. If I want to access the third item in the list and the fourth item in the list, then I can do what is considered in Python as slicing. I'm basically giving it a subset of the items in the list. The first number you're giving it is where do you want to start counting? What index do you want to start counting? And then the second number you're giving it is what is the index that you want it to go up to, but not including. So it's going to not include index position 5. So index position 2 is there's 0, 1, here's 2, and it's going to go 3 and 4. It's not going to include 5. If we push this down, so let's just see the output of this. Let's run this. Should put the rest of from orange juice, bacon, and pancakes. There it is. Okay. If I drop this down and say 4, then it will go up to, but not including pancakes. So let's run the module here, and you can see it stops at bacon, which who doesn't stop at bacon, right? All right, so this is considered slicing. Okay, very simple. There's other fancy ways that you can do it. It actually wraps around. And actually in Python, what's interesting is in Python is I can put a maximum like up to 10. Okay, and you're going to look at this and say, well, I don't have enough items in my list. That's probably going to cause an error. And actually it doesn't cause an error. Okay, so you can get away with things like that. Now, if you don't want to, let's say we want to go up to 4. If I do not include a number, then by default it's 0 for slicing. Okay, so it starts at milk, eggs, orange juice, and goes up to bacon. So one way we can access items in a list is via slicing. Another way we can access items in a list is just indexing the position. And we've already talked about that already. So if we say my list, get item number 4, which is the third index out of there. So that's just a standard, it's the number 19. So just standard indexing. This is via slicing. Make sure you can understand me. That's slicing whenever we do a subset of the list. Okay. All right. Another concept or another function feature of a list is that we want to add things to the list. Now that we have a list, we want to be able to add things to it. And we do it via the append function. And so we identify the list by name, the variable name, and then we add the period dot notation. So whatever your list name is, dot append, and then in parentheses, what do you want to add to the list? So if I want to add items to my grocery list, then I have to actually call, let me just change this stuff up. Let's call this grocery so it makes more sense. All right. So if I want to add something to my grocery list, I got to call it by name, grocery list, and then period or dot notation, append. Use my parentheses, and then what do you want to add to the list? Whatever you want to add to the list, you put it inside the parentheses. So let's just say I have paper towels. Let's just say paper towels. Okay, now let's print it and just see what my effect is. Print grocery list. And you notice it added paper towels to the very end. Okay, so that's one way that you can actually add items to the list is using the append. And then to remove items from a list, you say grocery list. Just like appending, you have to reference the variable. You can say grocery list dot remove, and then you identify what you want to remove. Let's remove, we don't want any eggs. Okay. And you can see over here, oh, why didn't it remove? Oh, I didn't print it. Silliness. Print grocery list. All right, over here now you can see the output. Milk, eggs, that's the original printing out of the list. That's this line of code right here. And then I remove eggs from the list, and then I print it again, and you can see that eggs was removed from the list. Okay. So I can reference items from the list using slicing. I can reference individual items from the list using an index. I can add by appending. I can add items to the list by using the append function, and I can remove items from the list by using the remove function. Okay, the one thing that we haven't really talked about yet is actually handling errors that get raised. So if I actually want to, let's say I want to remove grocery list dot remove, and I want to remove waffles. Okay, and then let's print our grocery list. Okay, so as we can see, waffles is not in our list. Okay, so when we try to remove waffles from our list, then what's going to happen? Well, what's going to happen is in Python, we're going to get an exception is going to get thrown or raised. In Python, it's called raised. In other languages, it's saying it's getting thrown. And so we're going to get an error. You know it's an error because it's bright red text, and it's telling us what line that it's occurring on, line 15. If we go over here in our code, we put our cursor there, we can see down here, line 15. Okay. And it also tells us in the stack trace that here's the line of code that caused the error. So it says value error, list.remove. List.remove x. X is not in the list. Well, waffles. Waffles isn't in the list. Okay, so we're going to be able to, and we'll learn this later on when we start getting into doing booleans and conditionals, being able to check if things are in a list first, if it's in it, is in, and so we'll handle these problems later on. Right now, we're not going to worry about the exceptions being raised, but I wanted you to be aware that as you are learning lists and you're practicing with your code, and if you try to do something like this, this is you're going to get an error. Okay, and we'll learn how to program against and guard against the errors surfacing, getting raised all the way to the program execution. But for now, just don't worry about it. All right, you can also get the length of a list by using the len function that we've already learned. It'll tell you how many items are actually in the list, so you can see. So let me just clean some of this up here real quick. I'll just work with this. So let's say list size is a variable. It equals len grocery list. So I actually want to store how big is my list in a variable called list size. And so we know it has 1, 2, 3, 4. It has 5 items in my list. Okay. So this list here has 5 items. Index positions go from 0 to 4. Right? 0, 1, 2, 3, 4, and there's 5 items. So I want to confirm there's 5 items by saying print list size. Oops. Okay, so I run it, and it's going to print out that there's 5 items in the list. Okay. All right, and then I just talked about what happens if we don't have an item in the list and we try to reference it. And if we do index using slicing or direct indexing, they have to be integer values. Okay. All right, so that's lists. And you're going to get some exposure to lists here during this week in this learning module. There's a bunch of challenges at the end of this learning module. So lists is something you want to get very familiar with using. Remember, it's hard brackets. All the entries use hard angled brackets to represent the list. Each item in the list that you add is separated by a comma. You can mix data types, so you can have strings, integers, floats, booleans, and things like that in the list. You can have other objects as well, but we haven't really got into that yet. You can append, use the append function to add items to a list. You can use the remove function to actually get items out of the list. And to reference items in the list, you can use direct indexing, just like we did with arrays, or you can use slicing. Okay. All right, the next topic, data structure that we want to talk about here is tuples. Tuples is really, don't make this overly complicated. A tuple is just like a list, okay? Except syntactically, it uses parentheses instead of hard brackets. So for example, down here, I create a tuple. Here's my variable called characters. It equals, remember in lists, we use the hard brackets. However, with a tuple, you use the parentheses. And that's really the one major difference syntactically. But now, semantically and behaviorally, what is the big difference between tuples and lists? Once you create a tuple, you can't change the contents. Okay, you can reference tuples just like you reference every other using slicing, direct index values. You can do all that, but you cannot change an item in the list though once it's been established. But other than that, they're the same thing, same concept. Okay, so that's tuples. Again, nothing out of the ordinary with that. Then we go to our last data structure, which are maps, or sometimes referred to as dictionaries. And actually, probably in Python, more referred to as dictionaries. But anyways, this data structure implements the concept of a key-value pair. Okay, let's look at this table real quick here. Okay, in this table, you have this concept of a key, which is this column, and a value. So this is almost like a variable, Marcus Fisher, this key. This key references this value. Okay, this key references this value. So at any time, if you want to get the value football, then what I'm enforcing is that you have to use its key, Marcus Fisher. Okay, so the concept of the dictionary is that it enforces this concept of a key and a value that have a relationship with each other. For you to reference the value, you have to know the key. Okay, now to create a dictionary, to create a map, you have to use curly braces, not the hard brackets. So in this case, you're going to be using something like this: favorite sports equals, these are that's the curly brackets right there. Okay, and so you create a variable name just like anything else, equal to, and then you have the curly brackets, the left and the right, or the opening and the closing. And then inside the curly brackets is you have to have these key value pairs. Okay, and so you start with what's the key? Well, let's just say my key is X. Okay, and then the value, you separate the key and the value with a colon, and then the value, let's say, is 23. And then you separate that with a comma. And then what's the other key value pair? Let's say Y is correlated with the value 31. And then let's just create one more. Let's say Z is correlated to 13. Okay, so that is my key value pair. You can't, it's not pretty printing, but you can print the whole favorite sports plus, and you can print it out. You can see it right here. Okay, so I created my dictionary. Again, key value pairs. Each key and value is separated by a comma, and then I just simply printed it out. Now, however, this is how it's used, because you typically just don't print the whole thing out like this, but this is how it's used. So let me just add some space here. So let's say I wanted to print favorite sports, and let's say I wanted to print the favorite sports of X. Okay, so if I wanted to do something like this, then what I would do is favorite sports is the variable name of the dictionary of the map, and I'm using an index just like we did with lists. I'm using an index, but instead of identifying what position that I want, what item that I want, I'm using the key to reference what value I want. So I want the value that's been associated with the key X. Well, if we look at our data structure, the key X has been associated with the value 23. Okay. So it's kind of like username password. The password is associated with the key. So you could do a username here, and then what's the password? I mean, you actually wouldn't implement that because then it's visible in the file, but just trying to give you that association. Okay. So look over that, dork around with these dictionaries, and then you got a couple ways you can replace items. So you could say, let's go back to our file here. You could replace an item. I could say favorite sports. I can use my index of X. And what do you want to change the value to? I want to change it to actually 25. Okay. And let's just see that it changed. Whoops. So we do see it. I didn't print it out again. Let's print it out here. All right, let's save that. And let's run it. Okay, so it prints that it's 23. That's the original value of the key X. And then I change it to 25, and then I print it out. So you reference it, and you can change the items. I can do that in a list, by the way. I don't think I mentioned that earlier. Like if I have this list right here, I can change the item of each list too by using an index as well. Okay. And then for removing items so that's replacing it or changing the value, I can also delete items from the list as well. Okay. Now we can't join maps together. That's one big difference between that and lists. All right, so this was Learning Module 3, talking about lists. This was an introduction to it. When we get into algorithms and using these, then we're going to get into a little bit more, some of the more fancier ways of using these things, especially maps. Dictionaries are pretty powerful. So anyways, here's your challenges to make sure you understood what these concepts are. And I will see you in Learning Module 4.